Picture this. It's Saturday afternoon, and Jay has just been given £200 for his birthday. Now, Jay could absolutely spend it all in one go. Trainers, food, a cheeky trip to the cinema, gone by Monday. But instead, his nan says, put it somewhere it can grow. Jay's not convinced. Money does not grow. It just disappears from your account when you buy snacks. But he listens. He puts the £200 into a savings account that pays 5% compound interest every year. At first, that sounds boring, but this is where the story gets interesting. After 1 year, the bank adds 5%. 5% of £200 is £10. So Jay's money becomes £210. Nice? Not life-changing, but free money is free money. Now here's the key part. In year 2, the bank does not add 5% of the original £200. It adds 5% of the new amount, £210. So now Jay is earning interest on the money plus interest on the interest. That is compound interest. It is money growing, then the growth growing as well, a bit like rolling a snowball down a hill. At first it looks tiny, but every roll adds more snow. And because it's bigger, it picks up even more snow next time. That is the whole idea. Compound interest is repeated percentage increase. And the easiest way to handle it is with a multiplier. If something increases by 5%, you now have 105% of the original amount. 105% as a decimal is 1.05. So a 5% increase means multiply by 1.05. A 4% increase means multiply by 1.04. A 10% increase means multiply by 1.1. So instead of adding the percentage again and again, we multiply. Now let's turn that into a formula. The final amount equals the starting amount times 1 plus the rate over 100, all to the power of the number of time periods. That sounds longer than it actually is. It just means start with the original amount, find the multiplier, then raise it to the power of how many times the interest happens. So for Jay, the starting amount is £200. The interest rate is 5%. The multiplier is 1.05, and it happens for 3 years. So the calculation is 200 times 1.05 to the power of 3. Now grab the calculator, type 200 multiply 1.05 power 3 equals. The calculator gives 231.525. Because it is money, we round to 2 decimal places. So after 3 years, Jay has £231.53. He started with £200 and without adding anything else, it grew by £31.53. That is compound interest doing its thing. Let's try another one. Aisha puts £650 into a savings account. It pays 4% compound interest every year. How much will she have after 5 years? First, find the multiplier. A 4% increase means 104%. 104% as a decimal is 1.04. The starting amount is £650. The number of years is 5. So the calculation is 650 times 1.04 to the power of 5. On the calculator, type 650 multiply 1.04 power 5 equals. You get 790.824388656. Round it to 2 decimal places. Aisha has £790.82. But here's a classic trap. If the question asks for the final amount, the answer is £790.82. But if it asks how much interest she earned, you subtract the original. 790.82 minus 650 equals 140.82. So the interest earned is £140.82. Final amounts and interest earned are not the same thing. Now, compound change can also go the other way. Imagine a laptop costs £1,200, but it loses 7% of its value every year. That is called depreciation. If it loses 7%, it keeps 93%, and 93% as a decimal is 0.93. So the multiplier is 0.93. If the laptop loses value for 4 years, the calculation is 1,200 times 0.93 to the power of 4. Type 1,200 multiply 0.93 power 4 equals. You get 897.662412, rounded to 2 decimal places. The laptop is worth £897.66. So here's the big idea. If the amount is increasing, your multiplier is bigger than 1. A 6% increase is 1.06. A 12% increase is 1.12. A 3% increase is 1.03. If the amount is decreasing, your multiplier is smaller than 1. A 6% decrease is 0.94. A 12% decrease is 0.88. A 3% decrease is 0.97. And the power tells you how many times the change happens. Not always years, just how many times. If interest is added yearly for 5 years, the power is 5. If interest is added monthly for 6 months, the power is 6. So whenever you see a compound interest question, think of the story. The money grows, then the growth grows, then that growth grows again. Do not work it out slowly year by year unless you have to. Find the multiplier, use the power, type it carefully into the calculator, round money to 2 decimal places at the end, and that's compound interest. Not scary, just repeated percentage change with a little snowball effect.